All right, welcome back. This is Gen Chem 1-1341. I'm going to work through questions 8 through 13. The first question here is 2.95 times 10 to the fifth KL or kiloliters is how many milliliters? Now, to answer this question, what I'm going to do is I'm going to switch to the whiteboard so that I can work this one out, write this one out. So here we go. 2.95 times 10 to the negative fifth KL. This is the same. This is in scientific notation. It's the same as 2.1234295 kiloliters. Okay. Now, in order to answer this question, you have to know that 1 kiloliter, just like 1 kilometer, is equal to 1,000 liters. So I'm going to put that conversion there. 1 KL equals 1,000 liters. Okay. Now this question, though, is getting at, well, how many milliliters? So in order to answer this question, I have to know that 1 liter equals 1,000 milliliters. 1 liter is 1,000 milliliters. So what I'm going to do is I'm going to say 0.0000295 or 2.95 times 10 to the negative fifth times 1,000 is equal to my answer. Now I got to get my calculator on my phone and thing corrected. I'm not going to use my calculator on my phone. I'm going to use my actual calculator. 2.95 times 10 to the negative fifth times 1,000 times 1,000. And whenever I multiply this number right here by these two conversion factors, times 1,000 divided by 1, I get 29.5 milliliters as my correct answer. And so whenever I flip back to my exam, I see that my best answer option is answer option C, 29.5. So question, oh, I messed up my number. And that's not well. Okay. Question number 8, the correct answer is C. And I'm bubbling my Scantron here so that I can bubble it all properly. Okay, there we go. All right, so C is the correct answer. Next up, the mass of a 1 kilogram lead brick appears to have a mass of 949 grams. From your measurement, what percent error is in your calculations or in your measurement? So basically, you're told this lead brick has a mass, or this lead brick, which is 1 kilogram. So that's the theoretical mass. But then you measure it and you find that it's 949 grams. So this is a question that basically what you do is take 949 divided by 1,000, because 1 kilogram is 1,000 grams. And you end up with 0.949. You multiply that by 100, and you end up with 94.9%. Okay, so the best answer for this, given the different options, is going to be, sorry about that. I was looking at the wrong thing. I was thinking about the wrong thing. I was thinking about theoretical and actual yield. So to think about this question in a different way, let's go back to the PowerPoint. Percent error calculation. Percent error is going to be calculated by your experimental, which in our case was 949, versus the true mass. So 949 minus 1,000. And then I'm going to divide that by my true mass, which is 1,000. So divide by 1,000. And I'm going to multiply this by 100. And that's where I'm going to get negative 5.1. But if you look at this equation, I'm going to annotate this. If you look at this and this right here, that tells you that we're working with an actual value, or sorry, an absolute value. So our correct answer, our best answer for this question is going to be, switching back to the right screen, is going to be A, 5.1%. It's question 9A. Good. Okay. The next question reads, which statement about significant zeros is true? And to kind of give a little bit of an idea of some significant zeros or insignificant zeros, I want to write some numbers. So if I wrote this number, 100.000, there are a total of 5 zeros in this number, and all 5 of them are significant. If I wrote this number, 10000, I've also written 5 zeros, but in this case right here, not a single one of those zeros is significant. And the only reason for that is because of this decimal place, or that decimal being present. These are all significant. None are significant. Okay, so it's important to think about a decimal place, and if that decimal is to the right of your non-zero digit, then it's going to be significant. So let's use that kind of idea whenever we look at question number 10. Which statement about significant zeros is true? Zeros to the right of a decimal are always significant. Answer option B, zeros are never significant. Answer option C, zeros to the left of a decimal are always significant. And zeros in between non-zero digits are always significant. Okay, zeros to the right of a decimal are always significant. And if we use the example that we used right here, to the right of a decimal are always significant. Okay, but what if we had this number, 0.000105? This is significant, but these zeros are not. These are to the right of a decimal, but they are not significant zeros because they are to the left of the only non-zero digit. So now let's go back to our answer options. So A is going to be out. B, zeros are never significant. Well, that's incorrect because there are some zeros that are significant. Zeros to the left of a decimal are always significant. Well, again, we've got this tricky place where we look back at the whiteboard. Well, these zeros are to the left of a decimal. This zero is to the left of a decimal. So it wouldn't be appropriate to say that zeros to the left are always significant. So that answer option is out. But then answer option D, zeros in between non-zero digits are always significant. They're in between non-zero digits. So an example would be 101. So 1, 0, 1. That would be a significant zero. So D is our best answer option for question number 10. All right. Next up is question number 11. How many significant numbers are in the solution for 94.68 minus 32? Okay. There's probably a tendency for people to look at this as 94.68 minus 32.00. But we got to remember our rules for when it comes to subtraction and addition for that matter. When we look at subtraction and addition, we look for the number of digits or number of decimal places. And 94.68 has 2 numbers or 2 levels of precision, 2 decimal numbers. 32 has 0. So our answer has to follow the fewest number of significant or fewest number of decimal positions, which is from our 32 with 0 digits or 0 decimal places. So our answer then, what we're going to do is basically look at 94.68 minus 32, and we're going to be left with an answer that is basically 62. So our answer only has 2 significant numbers in it. Okay, Question number 12. How many significant figures? And actually, let me, 11 is B. 12. How many significant figures to the right of the decimal will the product of 94.68 times 4.000 have? Do not convert the number to scientific notation. Follow the guidelines for multiplication and significant figures. Okay, so we've got 94.68 times 4.000. Whenever I do that, I end up with this number right here, 378.72. Okay, now when it comes to multiplication and division, we're looking for the number that has the fewest significant figures. Well, 94.68 has 4 sig figs. 4.000 has 4 sig figs. So our answer has to have 4 sig figs. Now, this answer of 378.72, which I think shows up backwards in your screen, 378.72, that 378.72 is 5 sig figs. So we have to have an answer that only has 4 sig figs. And so we're left with 378.7. So we've got an answer with 4 sig figs, but what is our question asking? How many significant figures are to the right of our decimal? Now, our answer, which I'm going to type up here in red, is 378.72 as a 0.7 to the right of the decimal. So we only have one number to the right of our decimal. And therefore, A is our correct answer for number 12. Okay. Convert 3.02 times 10 to the negative 5th from scientific notation. Okay. We want to look at our exponent. We have a negative exponent. Therefore, our number is smaller than 1. 302,000 is larger than 1. So that's out as an answer option. What we are looking to do is move the decimal 5 places left. So we need to find a number that moves the decimal 5 places. So if the decimal is moved 1 place, we would be looking at 0.302. So I'm going to go to answer option B. I'm highlighting where the decimal was between 3 and 0. 1, 2, 3, 4. If I moved the decimal 4 places, I would look at 0.0003020. Okay, this answer, B, is not a good answer option because where did this 0 come from? That's one issue. So now we're left with answer option C. 1, 2, 3, 4, 5. 0.0000302. C is our best answer option for this question. Okay, so question number 13 is C. All right, well, I'm going to go ahead and stop right there. I hope this is helpful. Have a